My YouTube channel, guys. We're still under Mechanotechnics. Oh, sorry, this is N6, right? It's not N5. This is N6. This is N6, right? Okay, we're still under Mechanotechnics N6. This is Conical Clash problem 3. So, but here is written 1.10, right? I've given this example. So let us take it. I advise you to watch my previous video based on Conical Clash. There's an introduction there. You can watch them then so that you'll understand what is going on. But nevertheless, if it's your first time watching my video, please subscribe there. Okay, example 1.10 read as follow. The mean diameter of the conical clash is 280 and the cone has an included angle of 34, the surface width of 68 with coefficient of friction of 0.325, the pressure initial limited to maximum pressure of 80 kilopascal, and the clash rotates at that 1200. Says calculate number 1 the inner and the outer radius of the cone clash. Okay, the outer diameter, not the radius. Okay, it's fine. Outer diameter. So let us collect the data here, guys. Can collect data for you here. We have data. What do we have there? We've given the width. It's there. Here it's a width 68, which is the same as 0.068 meter. When you divide by 1000, we're given also mean diameter, whereby the mean diameter, I've given that the mean diameter is 280. This is same as 0.28. Then from the mean diameter, remember mean diameter is the same as R1, R plus R divided by 2. No, mean diameter is the same as this, R over R plus R divided by 2. This thing is RF, right? To find RF, we're supposed to divide by what? By 2. Mean diameter is the same as the sum of these two. Sorry, not, yeah, mean diameter is the same as R1 is R plus that. You understand? So mean diameter, D mean, is the same as R plus R. So right, so we have R plus R. Then if you want the RF, you can simply divide this by 2. Then that will be 0.14 meter, right? So here we have now the pressure. We have given the pressure, which is 80 kilopascal, and rotates at 1200 rest per mean, and we're given what again? The angle, which is 34, but this said, remember we're dealing with semi groove, not included. To divide by 2, then you'll find your semi groove angle to be 17 degrees, right? So this is what we have so far. So without wasting, we know that if you are dealing the said question 1, calculate the inner and the outer diameter of the cone. Number 1, you can see solutions. Okay, what you have to know again. Okay, to find this, remember this is a cone clash, right? You must know the cone clash. We'll be dealing with this triangle of this manner. Here we have R minus that. Here we have our angle there. Semi dialect. We have our semi cone there, angle that is included there inside of this. This is our angle there that we have. Then here we'll have the width on our hypotenuse. So opposite, as you can see, opposite over hypotenuse is equal to what? To sine. So using that, then we can easily take our equation, right? Then sine our angle there. Opposite is what? Is r minus r divided by weight. Then here we have sine. Included angle, it was 17 degrees. You have seen our, we don't know r, we don't know that. What about the width? We are given there. Here it's our width there, which is 0.068. Okay, can multiply by that, or make r minus r. When you multiply, this will be 0.068 multiplied by sine 17 degrees. Then r minus r will give us or you can call this equation 1 if you want, isn't it? You can call this, you can say this is equation 1, no problem. There's nothing we can do. What do we know about? Okay, we're given RF, isn't it? We know that RF is R plus R divided by 2. But RF, we found that was 0.14. Then this is R plus R divided by 2, because here it's our RF there from the mean diameter. So this is what we have so far. Then you can multiply there by that 4, be R plus R, simply 0.14 multiplied by that 2. This is same as 0.28. Then it's R plus R there. So this is what we have now. I can say R, then I can take that R to that side, it will be 0.28 minus R. I can call this equation 2. Now can use substitute method. I can say substitute equation 2 into 1, where it's our equation 1. Here it's our equation 1 there. You see, let me do like this. Let me just copy this then and paste it here. Right, this is our equation 1. So if you want, you can, okay, where we see R will be replaced by the whole of this, so we'll have 0.28 minus R. We have also this minus R again. This will be minus R, the one that we have there. So this is equals to, you can punch this on the calculator, will be 0.0199. all right, then now math, we know here we'll have 0.28. R and R is the same, will be 2R, 0.0199. Then I can make this to be positive. I can take this to the other side and take that to the other side. You understand? Let me do this so that you'll see what I'm trying to say. This will be 0.28 minus 0.0199. This will be what? Positive. When I take this, will be 2R now positive. Then I can divide by 2R both sides, by 2 only. Then I can see our R will be 0.28 minus 0.019 divided by 2. Therefore our R, if we subject this on our calculator, put this on the calculator, look at this to be 0.13. This is in meter. It is in meter, right? This is what we have. Now we have, so what about the big R now? This is the inner radius, the outer radius. We can take it from which equation? We're supposed to substitute from this one. You see, from here. We can take it from here. There we set R from there. Our big R was equals to that 0.28 minus R. Then we can substitute R here. We know that R is 0.13. Our outer radius will be 0.15 meter. But what the question stated, they want the inner and the outer radius, right? Diameter, so not radius, diameters. So we know that diameter, okay, inner diameter, I can say inner diameter will be 2 multiplied by R. Then I'll say the outer diameter will be 2 multiplied by R. So then here I have 0.13. Here I'll have 0.015. So this will be 13, right? Sorry, will be 0.26 here, 26 meter. Then this one will be what? 15, isn't it? This will be when you multiply that will be 0.8 meter. But if you want this to be in millimeter, multiply by 1000, multiply by 1000, then this will be 260 millimeter. Then that one will be 300 millimeter. So this is what we have, guys. Anyway, so what we have now, question 2 says determine the axial force required to engage the clash. To engage, take note there, to engage the clash, which is number 2. We know that the force to engage the clash is equals to F axial into 1 plus coefficient of friction into tan groove angle, like that, semi-groove, semi-cone angle there. So we don't have this, guys. That is what is limiting us, axial force. If we can find axial force now, we know the axial force there. We want the axial force. This is same as 2 pi r into r minus r. Then here we have remain 2 pi. Then our radius, the small one was 0.3, the outer was 0.15, minus the small one 0.15. Diameter pressure, it was 80 times 10 to the power of 3. Then axial, if we press this on calculator, we'll find that this to be 2696, right? 2696. It is that. Oh, this is too much. This is not there. Sorry, guys. Sorry, wrong punch. This will be 1306,903. This is in Newton. It's a force in Newton. So we can simply use our equation, the one we've talked about now. We can use this equation here. So yes, we have the force now. So F engaged. Now we substitute 1306,903 into 1 plus the coefficient of friction. What it was coefficient? Where is the coefficient? We don't have the coefficient here. Where is the coefficient? I did not write it. Oh, here it is. 0,325. 0,325. 0,325 divided by 10, which this was 17. So till you punch this, you'll have that your force engaged will be K2696,176 Newton. This is what we have. Then let's check another question there. Okay, number 3 says the power that the clash can transmit. The power. Guys, power. Number 3, the power. Power is equals to 2 pi nt over 60. So we don't have torque is limiting answer. So, but the torque, we know that the torque is coefficient of friction multiplied by axial force multiplied by Rf divided by what? Sine there of that. Then coefficient of friction was 0,325 multiplied by axial. What was the axial? Or axial there? Not engage. Axial. Not the engage. Here is the axial. Is that 1306,93 1306,93 or multiply by 1306,903 multiplied by ref was 0,14. This was 0,14. Then divide by sine our angle 17 degrees. Then we punch this, get the torque. What is the Mr. Torque there? 203,385 Newton per meter. So this is simply our torque, but we want the power. Remember, we said the power is 2 pi nt divided by 60. So 2 pi n was 1200. Then the torque is 203,385 divided by 60. Therefore, the power is equals to what here? Power is measured in watts. This is simply 25,558 Newton per measured in Newton per meter. Power it's in so guys, power it's in this is 25,558 times 10 power of 3, which is the same as kilowatts measured in watts. So this is what we have typically. So okay guys, so this is what we have so far. So guys, thank you for watching. Please subscribe to my YouTube channel and feel free to comment and share this to your fellow classmates. All the best. Thank you for watching.